Okay, so welcome to the first of the presentations. Obviously, this is in chapter 2 of the book, and you can read it better there. All I'm giving, as I said before, is a bit of an overview of why we're doing some stuff. So if we know the ratio of one value to another, that helps us work out unknown values. What does that mean? Well, for example, if we had a solution of a particular strength, then if we want to know how much of a drug we need to put into solution to make a different amount of that product, then working with ratios will help us. And the idea that it presents in the book is that of proportional sets. And this is really talking about what a ratio is. So it gives you a series of numbers, and this might be one of those series of numbers. 1/2 is actually the same ratio as 2/4. That's the same ratio as 50/100 or 364/728. So the relationship stays the same in those proportional sets. How does it help us? Okay, so if we know the ratio, any one of the above numbers is not known. So if, for example, in the second series of numbers, instead of 2/4, we don't know how many over 4, then we can work it out from the ratio. But that relies on the fact of it being the same ratio. If instead of 1/2 and 2/4, etc., we had perhaps 1/2 and 2/7, 365/89, hopefully you can see that that's not going to be the same thing. So we can't predict in any one of those situations what an individual number would be, because the relationship isn't there. And that's why we talk about rational numbers. That's the purpose of it. Okay, so if we now think about how proportional sets relate to percentages, in chapter 2 it shows you how the relationship of one number to another relates to proportional sets relates to percentages. So, for example, if we needed, say, in a 300 ml of a drug solution, we needed 30 grams of a solid to make our solution. Those two we know. Then we're asked to make a further 400 mils of the same solution. What we don't know yet is how much of the solid we need to put in to make another 400 mils of the same strength solution. But using the proportional sets, we can work that out. So the first thing we can say is that there are 30 grams of the drug in 300 mils. So therefore, in 400 mils, we don't yet know how many grams there are, so we call that X. What we do know is that the proportion is the same. So 30/300 is the same as X, our unknown, over 400. And if you're confident on equations, then you'll know that to find X, what you do to both sides of an equation is to work out how you get to X on its own. In this case, the right-hand side of the equation has X divided by 400. So if we multiply both sides of the equation by 400, then we'd have X on the right-hand side. And on the left-hand side, we multiply that by 400 as well. So that becomes 30 times 400 over 300. That gives us X. So for 400 mils, we need 40 grams. Now, if you're not sure on any of those things, if working with equations and things is something you're really not confident about, put a couple of links in Student Central to help you. I would say that it's really, really important that you become familiar with doing this. the whole of the rest of your course will depend on you being able to do some straightforward manipulations of numbers like this. So if you're not sure, if any of that was confusing to you, really do have a look and get confident with working out how to solve for x. Okay, so we've looked very briefly at what proportional sets and fractions are. Well, fractions are really another way of saying a ratio of one number to another. So what are decimals? Well, actually, they're just fractions, but they just happen to be the number divided by 10, and percentages, similarly, are just a fraction, but making sure the denominator, the bottom number, is 100. So whatever number you have to manipulate, whatever fraction you have, you manipulate it so the bottom number, the denominator, is 100. And that gives you your top number is your percentage. Just a very quick run through there. I hope that's been clear for you. If it's not, then again, look through that chapter. Be confident in what you do. These are really basic things. You have to be able to do these. So my inspirational person today is this lady. Some of you may recognize her, some may not, who is been awarded a doctorate from the University of Brighton, Dr. Alison Lapper. I'd encourage you to go and have a quick look at the things she's done in her life, quite inspirational.